Welcome students. So today's topic is Euclid division lemma. So first of all, we will just try to understand the meaning of this heading, that is Euclid division lemma. So Euclid is the name of a mathematician who has given this, and it is a theorem, or it is the concept which is related to the division, and the new word which is introduced here is a lemma. So first of all, we will understand the meaning of lemma. So when we talk about lemma are the proven statements. These are some statements which does not require any proof. These are self-satisfactory statements. That means we have to accept it as it is. They are derived from various calculations, various practical examples, or in other words, we can call this as a auxiliary theorem. Auxiliary theorem, or we can call it as a helping theorem. Similarly, we have in our English language, we have our helping verbs or the auxiliary verbs which support the main verb. They are known as a helping verb. Similarly, in mathematics, we have a lemma. Lemma means they are the auxiliary theorems, or they are the helping theorems which are used or which helps in proving the bigger theorem or the major theorem. So now, let's start with the Euclid division lemma. So let's see the statement of this. So the statement states that if we take any two positive integers a and b, which means that we have to take two positive integers. Two positive integers. Now these two positive integers, we have given them name a and b. Now when we assume any two positive integers, the condition is that a is greater than b. That means whenever we select two integers, so the bigger integer will be represented as a and the smaller integer will be represented as b. Then there exists a relationship between a and b. So when we select two integers a and b, so there is always a relationship between a and b which is given by a is equals to bq plus r. So that relation is a is equals to bq plus r. Now many of you wonder that what is this a is equals to bq plus r. So just to find out the relation, this relationship, that is a is equals to bq plus r, Euclid has given us the name division. That means this relation is derived with the simple division. So let's try to understand this Euclid division lemma with some simple examples so that it will be clear in your mind. So first of all, we have to assume two positive integers. So let's take any two positive integers. I'll take two integers. The first integer, let's take 20, and the second integers I will take it as, let's suppose, 50. Now these are the two integers, 20 and 50. Now as per the condition of Euclid, the integers a and b, a is always greater than b. That means out of these two values, whichever integer is bigger, that will become the a. So here this 50 is represented by a and this 20 is represented by b. So my value of a is 50 and value of b is 20. You may write it as 50, 20 also. Always remember the integer which is bigger is always taken as a. Now let's perform the division. Now when we divide any two integers, we always know that we divide the bigger integers with the smaller integers. So let's divide this bigger integer. So bigger integer is 50. So let's divide 50 by 20. So 20, we will count the table of 20. We know that 22s are 40. So the remainder is 10. Now can we carry forward the division? No. As a simple division, if you don't want to take division into decimals, we have to stop the division here. Now when we divide the two numbers, this number is known as our dividend, this number is known as our divisor, this number is known as our quotient, and this value is known as our remainder. Now from this division, we can see that this dividend was our a, this divisor is our b. Now this quotient has become our q and this remainder has become our r. So we can see that two values are there, q and r. So this q is our quotient and this r is our remainder. So we know the value of a. So from these two integers, the value of a is 50. We know the value of b, 20. Value of b is 20. Now this q we will get it from the quotient. So quotient q is, the value of q is 2 and the remainder r, the value of r is 10. So just I will note it down all the values. A is equals to 50, B is equals to 20, Q is equals to 2 and R is equals to 10. Now we got all the values. Let's try to express in this format. So A, in place of A I can write it as 50 is equals to, in place of B I will write 20, in place of Q I will write 2, in place of R I will write 10. So now just check whether this condition satisfies or not. So our LHS is 50. Now let's calculate the RHS. In RHS 20 twos are is 40. 40 plus 10 is 50. That means our RHS is also 50. LHS is also 50. So this condition is true for these two integers 20 and 50. Now let's try to understand with some more example. Let's take some other examples also so that it will be clear in your mind, because this Euclid division lemma is very important topic from the first chapter, and one question for 3 marks is always asked in the final examination. So let's assume, or let's take few examples more. So let's take two other numbers. This time we will take some bigger number. Let's take the number is 130. One number is 130, and let's take another number. Let's suppose it is, let's say it is 9. Another number is 9. So now out of these two numbers, the first task is we have to find out the value of A and B. Now to find out the value of A and B, the relation is here. A is always greater than B. That means the integer which is bigger or which is greater is always represented as A. So this is our A, and the smaller value is always represented by B. Now once we get the value of A and B, now we have to perform the division. So now let's divide the value. Divide the A, that is 130, is divided by 9. Now let's perform the division. So 9 ones are 9, subtraction, 30 minus 9 is 4, this 0 will carry, 40, 9 4s are 36, remainder is 4. Now here we have to stop the division, because the main rule you have to remember is that we can never take the division in the decimal while performing the Euclid division lemma. You have to divide it up to integers only. So here the remainder 4 is there. Now we cannot divide it. Now a value of A is 130, value of B is 9. Now our quotient, that is Q is 14. So value of Q is 14, and this remainder is our R. So value of R is 14. So R is 14. Sorry, R is 4. So R is 4, Q is 14, A is 130, and B is 9. Now let's try to express in the form of Euclid division lemma. That is A is equals to BQ plus R. So in place of A, I will write 130 is equals to, in place of B, I will write it as 9. In place of Q, I will write it as 14. Plus, in place of R, I will write it as 4. Now let's once more, we'll check whether the theorem stands or not. So our LHS is 130. Now in RHS, we can say that 9 into 14. So 9 14s are 126. You can perform the multiplication. 9, you can count the table of 14. 14 9s are 126. 126 plus 4 is 130. So now our LHS and RHS both are equal. Both are equal. That means this theorem states or stands true for these two values also. So similarly, we can take many values and we can perform the Euclid division lemma, and we can express two integers in this relation. A is equals to BQ plus R. Now let's try to understand the meaning of these two lines, because these two lines are very important, because up till this it is clear now how to express this. In the next upcoming video, I will explain with few more examples this. So now Q and R, the first condition which Euclid has given is that Q and R are always positive integer. As I told you that whenever we perform the division, this value is our Q and this value is our R. So if we will go in decimal in the division, when we perform the division and when we take the division into decimals, so this Q will be having a value in the decimals. So that's the reason Euclid doesn't want it that the Q should be in the decimal. That's the reason he has placed the condition that states that Q and R are the positive integer. That means the value of Q should be an integer and value of R should also be a integers. integers. In the previous video, we have already studied that integers are always a complete number. They cannot be in the form of decimal. So I hope that you are clear with this first point. Now second condition is given for r. That means the value of r is always greater than equal to 0. That means this value of r will always be equal to 0 or greater than 0. It can never be less than 0. That means it can never be a negative, which we have already learned. And now the second condition is given that r is always less than b. That means whatever is the value of remainder, it should always be less than our divisor. That means let's try to understand the same example. When we take, suppose again if I divide 130 by 9, 9 ones are 9, remainder is 4, and then we carry forward this 0. Now we cannot say that you can here this value of 1 is our q and this 40 is our remainder. We cannot do this way, because in this division the first condition is satisfied. The value of q is positive, value of r is also positive, and they are integers. But when we go through the second condition, the value of r is greater than 0. Yes, it is greater than 0, but value of r should be less than b. That means this remainder should be less than our divisor. If the value of remainder is greater than this divisor, that means that division is an incomplete division. You have not performed the complete division. So here we cannot say that this 40 is the value of r is 40. We have to perform the division again till when the value of r is less than our divisor. That's the reason we carry forward the division. The 9 4s are 36 and the remainder is 4. Now here in this case, this value of r is less than this 9. Now we can say that the second condition is satisfied. So when these two conditions are satisfied while performing the division, then only we can take the value of q and r from that division. And with the value of this q and r, we can express any two integers in the form of a is equals to bq plus r. So I hope I have cleared your each and every doubt in this. In the next video, we will come up with few more examples of Euclid division lemma. Till then, study well, keep working hard, and for other references, please refer for textbook and the other reference material. Please refer diksha.gov.in, or you can refer the Extra Marks app.